Okay, having a look through the topic assessment. To find the points of intersection, you put both curves equal each other and solve. So everything goes onto the one side. You notice where you can divide everything by 2, makes it a bit easier. Factorise or use your formula, find your x points. Now, if you look here, it is going to be the blue curve, take away the red curve. So that's me tidying it up, integrating it, and you've got your limits. Number 2. Okay, it's a bracket. Do I have, because that comes up as a -2, do I have the derivative of the bracket on top? The derivative of this bracket is 3x squared. I don't have it, but I can put it in 3 and balance. Now I've got the derivative of the bracket, I can now integrate. So this third sits outside, you add 1 to the power here, divide by it, and don't forget your c, and just tidy up. Part 2. Do I have the derivative of the bottom on top? That differentiates to disappear, and that differentiates to ex, so I do. So I do is log the bottom line, and don't forget your c. Number 3 is very easy to get caught out on. Look at the e function. To integrate an e function, you must have the derivative in front. The derivative of this is 2x. I've got an x. So if I pop the 2 in there and a half outside, I've now got the derivative in front. So I can integrate back, half sits there, sub in your values and subtract. Part 2. Do I have the derivative of the bottom on top? Well, sine does differentiate to give me cos, so I'm good to go. Log the bottom and put your values in. And number 3. I like this one here, number 3, because that's a bracket, sine squared. Okay, so how you differentiate a bracket, you must have the derivative in front. The derivative of sine is cos, and I do have it in front. So I'm ready to go straight into this. So integrate this, add 1, divide by it, derivative disappears, and put in your limits. Number 4, it's a bracket. Derivative of the bracket is -1. It's no good. Now, to be honest, you could either use substitution or you could use integration by parts. I chose to use substitution here. So remember, u is the awkward bit. Sorry, just looking here. U is the easy bit. So u is x du by... Sorry, I shall rephrase that. You could use substitution or integration by parts. I have used integration by parts. Okay, so u is the easy one, dv by dx is the harder one. So differentiate, integrate. How do you integrate this? It's the bracket. You must have the derivative in front. The derivative is a minus, so balance it outside. Now you've got the derivative in front, add 1 to the power and divide by it. So now I've got all my bits and pieces using my formula. So uv minus v du by dx, put in your bits and pieces. First bit doesn't change. Next bit, I would tidy this up, bring it out as 2/3, leave me the bracket. To integrate a bracket, you must have the derivative in front. Derivative is a minus, so pop your minus in and balance it outside. Now I'm good to integrate this. Add 1 to the power, divide by it. Tidy it up, sub in your 1, sub in your 0. Now you could try that by substitution if you want, and that would work out fine, or it should work out fine. I do tend to leave substitution. I don't really particularly like that method. This one here. Okay, we're trying to integrate a log. At this stage, I hope some alarm bells are going off and that you can't integrate a log straight off. So you have to use integration by parts. It's the only way of doing it. And u is the log bit, dv by dx is the other bit. So du by dx and v, just as normal, plugging it into integration by parts, your formula. Plugging it all in and just working your way through it. So basically, if you're ever asked to integrate a log, always use integration by parts, always. Number 6. Okay, I can see product here. So u is the easier one. It will disappear when you differentiate it. Sine 3x. So write it out as an integral. Where does sine come from? Cos gives me minus sine. So I need a minus, so minus and balance it. Derivative is a 3 and balance it. So it's minus a third. This will now go back to cos. Plug your wee bits and pieces into the right hand side of your integration by parts formula. Now if you look over here, what's going on? I could put by plus a third outside. I'm looking at cos 3x. Where does cos come from? Well, sine goes to cos, so it's just going to go back to sine. But I must have the derivative in front. The derivative is a 3, so I need a 3 in front, balance outside with a third. So outside you've got a ninth, and that goes back to sine 3x. Number 7. Oh, it's guiding you in this one. It's telling you to use partial fractions. You wouldn't have been able to get very far anyway because the derivative of the bottom, you have to multiply that out, and the derivative of the bottom is certainly not on top. So using your partial fractions and splitting it up into two separate integrals. So it's minus 1 over x add 1 dx plus 2 over that integral. Do you have the derivative of the bottom and top? Yes. So that's minus log the bottom plus 2 log the bottom. You could tidy this up if you want, or you could just sub your numbers in and work through it. Number 8. Okay, I'm seeing a bracket there. So when I'm seeing that, I'm seeing it like this: x squared minus 1 minus 3. To integrate a bracket, you must have the derivative in front. The derivative is 2x. So I need to pop a wee 2.5 outside. So now I've got the derivative of the bracket. So add 1 to the bracket, divide by it, tidy it up. And remember, the derivative disappears. Number 8. Part 2. Derivative of the bottom is not on top. Okay, so whenever you've got a fraction, you're sort of stuck. You're thinking partials, fractions. You can't break that up at the minute. So the only thing you can do is divide. So take the top and divide it by the bottom. X into x goes once. So 1 times this. Subtract. X minus x disappears. Nothing minus minus 1 is a plus 1. So it goes in once plus the remainder over the divisor. Integrating 1, you get x. Derivative is on top, so just log the bottom line plus c. And number 9, last one. So volume, remember it's pi y squared. So it's pi, there's your y, so square it. Now I'm going to take you through how I square a bracket. Square the first. Remember, power to power means times, so that's x to the 6. Square the last. So a minus squared is plus 2 squared. X squared squared is x4. And then double the product. The product, the sign is minus. The number is 2, double it. x3 times x2, you add the powers, x5. Now, we need to get our wee limits. You have to find out where it crosses the x-axis. It crosses the x-axis when y is 0. So put it equals 0. Pull out your x squared. So x is 0 or x is 2. So that's our limits. Once you get to that stage, the rest of it should be straightforward enough.